Hi, I'm Mary. I'm going to talk about a little Lisp interpreter that I wrote in JavaScript. There's a blog post version of this talk at maryrosecook.com/post/little-lisp-interpreter. It goes through the same material but at a more sort of measured pace. Let's start by learning some Lisp real quick. Here's the Lisp atom 1, just the number 1. Here's the Lisp atom 1 just inside a list. Here's another list where we've got the first item, which is 1, and then the second item, which is another list, which has got 2 inside it. Here's an invocation of a function. The function is called first, and we're calling it on the list with 1 in it. And first takes a list and then returns the first item. So when we call first on the list with 1 in it, then we get back 1. Writing a Lisp interpreter is way easier than it sounds. You parse and then you interpret. When you parse, then you tokenize and then parenthesize. When you tokenize, then you take something like this, a string of completely unstructured Lisp code, and then you surround every parenthesis with spaces, and then you split on white space to get an array of tokens. So our tokens are parentheses, words, and numbers. Let's look at the code for tokenizing. On line 2, then we find every open paren and replace it with space, open paren, space. And on line 3, we find every closed paren and replace it with space, closed paren, space. And on line 4, then we split on white space. Now let's talk about parenthesizing. This is where we go from our array of tokens to an abstract syntax tree, which is a sort of douchey word for something that describes the structure of code. In our case, we're using an array of arrays to describe that structure. So you can see that in our main array, then the first item is a node which represents the identifier first, and then the second item is a list which has the literal 1 in it. So remember that that's pretty much the same structure as the code that we started with. So that's what we're aiming for at the end of the parenthesizing phase. Let's look at a few small examples, working our way up to more complex ones. So here we're just going to try and parenthesize the number 1. You can see here's the parenthesize function. You can see that there in the input, at the very top, we're taking in our array of tokens, and then we're also taking in a list, which is the abstract syntax tree we've built up so far, which of course starts out empty. So let's shift off the first token, which is, remember, the number 1, and we discover that it's a literal, so we call categorize on it, and then categorize discovers that it is a number and returns a object which has a type of literal and a value of the number 1. We pass that back from the categorize function. We then concat that onto the list that we've built up so far, which is empty so far. And then we call parenthesize again to deal with the remaining tokens. When we call parenthesize again, we try and shift off the next token, but there are no next tokens, so the next token is undefined. And so we just call pop on the list that we got passed in, which gives us back that literal node just again, and that's what we return from the function, which is the final abstract syntax tree. Now let's look at another example where we're trying to parenthesize the list with 1 in it. So the tokens we've got open paren, 1, close paren. Same deal, here's the parenthesize function. We shift off the first token. This time it's an open paren. So that means we're going to call parenthesize on line 6, starting a fresh new list. That's absolutely crucial. And we're going to pass in the rest of the tokens that we've got left. So let's dive into that parenthesize call. We're going to shift off the next token, which this time is a 1. And seen all this before, no point rehashing it. We're going to get back an array with the literal 1 in it. We're going to call parenthesize again to deal with the rest of the tokens. And then we're going to shift off the final token, which is a closed paren, and that just calls for us just to return the list that we've built up so far. And then we're going to return that from the parenthesize call, return that to the very first parenthesize call, and so now we've just got an array with the literal 1 in it. We're going to push that onto the list we've built up so far, but then we're going to call parenthesize again on line 6, and we already know that we're just going to pop because we've run out of tokens, so there's no point rehashing all of that again. And so this will be our final output, just an array with the literal 1 in it. Final parenthesizing example, we're going to try and parenthesize that piece of code that we started with. So remember, it's an invocation of first on the list 1. So we've got an open paren, first, open paren 1, close paren, close paren. So here's the parenthesize code again. I've seen a lot of this before now. Open paren, call parenthesize, get back, this time the identifier first inside an array, call parenthesize again to deal with the rest of the tokens. Now I've seen all this before because we've got open paren 1, close paren. So we'll just skip straight ahead to where we've got an array with the literal 1 inside it. Then we're going to push that onto the list that we've built up so far. But remember, now we've actually got a list that we've built up so far that's got something in it. So this what we get back from that is something that looks very like the final abstract syntax tree that we're aiming for. But there's a little more work to do. So we call parenthesize again and deal with that close paren, get back the list again. Now we're back to the inner call, and then we're back to the original call. And so basically the same abstract syntax tree we had quite a while ago. We call list push, then we call parenthesize again, but that's just pushing on and then popping off again, so no point dragging ourselves to all of that again. We return, and this is the final abstract syntax tree that we're going to try and interpret. So interpreting is going from the abstract syntax tree to the actual output of the program, which remember is 1. Let's see how it works. Here's the interpret function. You can see that it takes the abstract syntax tree as input. And it also takes a context. Now what's a context? A context is, for our purposes, all of the variables that are currently in scope pointing at their values. So you can see that context has a scope, which is those variable mappings, but it also has a parent, which would point to the scope containing this scope, which of course might also have a parent which would point to its parent, and so forth ad infinitum. So we've got no context when we start off, so we need to make one. So we call new context and we pass in library. And library is the extensive library of functions that is built right into this toy Lisp, i.e. just the first function. So let's remind ourselves that first just takes some sort of array, returns the first item. So now we've got our context, and we can call interpret again, but with exactly the same input, but we can actually finally start dealing with the input. So on line 4 we discover that the input is an instance of an array, and we call interpret list. Interpret list takes the input again, and the idea here is just purely to walk through the list, for each item in it, call interpret on it. So we're going to call it interpret again and again, once for each item in the list. So let's see what our first customer is. It's the first identifier, and with the name of the function we're trying to run. So let's call interpret on that. We discovered that on line 6 that it's an identifier, so we call interpret ID on it. And interpret ID looks up first in the context, discovers a for reals JavaScript function, and now needs to create a new invocation node to swap in for the old identifier node. So that identifier node in the very top left there is going to get swapped out, and we're going to create a new node here. So this new node is just an object again, but this time type function, and its value is a function that will run the first function on whatever args are passed in on line 4. Now we don't have those args yet, but we will do when we try and run that function. So we swap that in, and now our second customer for the mapping over the list of input items is the array which has literal 1 in it. So let's see what happens. Now that array is of course itself an instance of an array, which means we need to call on line 5 interpret list again. So now we're starting a fresh new call of interpret list, but with a different list of course. This time there's only one item in this list, just the literal 1. So we just call interpret on that on line 6. And we just return the value in at that node, which is just the number 1. So we've now got our inner list complete, it's just an array of 1 in it. And that completes our outer list, which has the function that we're actually going to run as the first item, and then the array of arguments as the second item. I'm sorry, the rest of the list is all of the arguments. This, we're only passing in one argument to first, and that's that array with 1 in it. So, we discover that the first item in this list is a function, so it's something that we need to run. We then go and grab that function on line 9, so it's ready to go. We grab the arguments that we're going to call on it, pass into it, and then we actually invoke it. So we're going to call that function on the arguments that are passed in. Now let's remind ourselves of the first function, the definition. It takes an array, in our case just an array with 1 in it, and returns the first item, which gives us back 1, and we're done.